Hello everyone, my name is Hannah Olson and I'm here from MyStem Kits to talk to you today about our wind farm kit. This is a kit that is available freely to everyone and you can access it using either Tinkercad or Instructables. In Instructables, simply search for MyStem Kits, and in Tinkercad, log into your account and then go under the Learn tab and see more projects. Once you've done that, look for the MyStem Kits logo. These open source lesson plans and kit will then be available for you to use, explore, download, and do whatever you would like with it, including modify the designs. So, let's get started talking about how you might use this. For this kit, the open source lesson plan is a middle school lesson plan that does a cost-benefit analysis in a real-world scenario that utilizes surface area and discusses the benefits of renewable energy. So, that's one of the activities you can do with it, and we have a whole model eliciting activity designed around that, where the students are actually being their own engineers. They're solving a problem on behalf of a company that has asked for their opinion. So it's real world, it's problem-based learning, and the students really enjoy it. Some of the other things you can do with this kit are from elementary all the way up to high school, and you can talk about human impact as well as renewable energy and discuss the similarities and differences between these wind farms and the wind farms we see out in the world. You can also use it to talk about a lot of different math things and do a lot of good graphing exercises. To assemble it, simply collect 4 hexagonal number 2 unsharpened pencils, as well as some pliers, scissors, and some thread. The first thing you do is take 3 pencils and insert them into the bottom of the stand. Then insert a stand foot on the bottom of each pencil. Next, take the spool and insert it onto the final pencil. You want to do so to where the opening is facing towards the long side of the pencil. Then take one of these centerers and slide it on. Now slide the whole pencil into the opening of the stand where the spool is on the more flat side rather than the long side. That's because the spool is going to go over the end of a table, and you're going to be able to test the effectiveness of the wind blade when placed in front of a high-powered fan. Take the other center and slide it onto the pencil in such a way that it is opposite the original center. That is so you don't throw off the weight balance of the wind farm. Next, choose which blade you would like to use. You can use any of our 4, or as I mentioned earlier, you can go into Tinkercad and design your own. Once you've chosen, slide it onto the very end of the pencil. Get your thread ready. Determine the length you have available and take a piece of thread that is twice that length. Fold it in half and tie a knot in the end. Then, take the loop part on your thread and string it through the opening on the spool. Then, take the knotted section of the string and pull it through the looped part of the thread to lock it in place. Next, you're going to need to de-support your weights. Simply take pliers and break the support off the bottom of the weight. Then, set your wind farm up in relation to the fan. For best results, the fan should be placed relatively close to the wind farm blades. Then, select one or more weights and loop them onto the thread where they're sitting on the knot at the bottom. Check to see if your wind farm itself is level. Depending on how the balance is, it may not spin freely if it is too heavy on one side or the other. Then, I can either tape or hold the wind farm blade in place so that when I turn the fan on, it's not going to blow the whole wind farm off the edge of your table, or in this case, the box. Once I'm ready, turn the fan on and you can time how long it takes to lift the weight all the way until it hits the spool. Once it hits, simply turn the fan off and you can reset with a new blade. This is a really good chance to compare the effectiveness of these different designs. This is really good for graphing. So option 1, how long does it take? Option 2, 3, 4. The challenge then is to get your students to design something even better than the 4 we provided. So in addition to the surface area or weight analyses you can do with this, you can also talk about unit rate and transformations. For unit rate, You simply take the length of the string that you have here and use the circumference, and then use the time to figure out revolutions per minute. Have the students analyze whether by weight or by cost, whether it's a proportional relationship. You can look at graphing linear versus non-linear functions. There's a lot of fun things you can do with this in middle school. In elementary, it's just good for explorations, getting the students to design, to test their own designs. And in high school, you can get into some really interesting math, tie it in with engineering. So we hope you enjoy this kit. If you want to find more like it, simply visit www.mystemkits.com to see the whole library of over 150 standards-driven kits and curriculum. Thank you for listening, and we hope you have a spectacular day.